excited. We had close to 100 people register to join us today. We hope that you're going to find this webinar very useful. Today, we're welcoming several staff from the FAU Libraries Information Technology Services team to give an introduction to 3D printing. We will be taking questions at various times during the presentation. So any questions you can chat into the chat box at the bottom right of the screen. I will ask for your patience to bear with us through this presentation. It's our first time attempting this, streaming live on WebEx and Facebook Live. So if you have any technical issues, you can chat those to us also, and we'll try and troubleshoot those. Shortly after the conclusion of today's session, you're going to receive an email to your registration email. It's going to include links to the slides from this presentation, and we're also going to include a brief survey that we're going to hope you'll take a few minutes to fill out. It'll help us as we continue to plan for future presentations. And now that our housekeeping is out of the way, I'm going to turn this over to our presenters and give them the opportunity to introduce themselves and get right into the presentation. So with that, our first presenter up is Hansi, which you have presenter status, so you're all good to go.
All right, thank you, RJ. And once again, thank you everyone for joining us today. My name is Hansi Amboise. I'm a system administrator at the FAU Library. Why did I get into 3D printing? Just a couple of months ago, I was just reading about 3D printing. I didn't really have any experience with it until our IT director came up with the idea of getting a 3D printer for the library. I was like, okay, cool, sign me up. So I mostly picked it up as a hobby. I wanted to be able to create and print my own, stuff on my own. And I also wanted to learn about the technology. So as a beginner, I'm still learning about the technology, and also use that experience to share what we have been learning with the FAU community, and those of you who are beginners or who are thinking about starting 3D printing. So hopefully this presentation will kind of break the ice for you and make it easier for you to get started.
Hey, Hansi, sorry to interrupt you. They're still getting an echo when you're talking. Can you try and switch to a different mic? Do you have your audio mic on your webcam? Folks are reporting echoes issues.
Let me check. Give me 1 second. Give me 1 second. All right, I'm not sure. I don't see. Okay, is that better? Is that better? Can you hear me?
I can still hear you. If somebody can give it, Tony, I think you gave me some information. Can you tell me if you get echo? Yeah, he's still getting echo on that. So.
All right, so I'm gonna go ahead and switch to speaker and turn down my speakers. So I think it's feedback for now.
Yep.
All right. So let's continue. So So that was a little bit of why I got started with 3D printing. Now let me welcome my colleague Crystal, who will introduce herself and kind of let you know why she got started with 3D printing.
You're muted. Unmute. There you go.
Hey everybody, my name is Crystal. I actually got involved in 3D design honestly about 20 years ago. My first degree is actually a bachelor in computer animation and media arts. So I understand 3D space a lot. And when the 3D printers came out, it was like, and then, Mahesh brought one into the library IT department and I jumped right in with designing my own stuff. So that's kind of where I fall into it. I also do, gaming and cosplay stuff. So it's right up, make your own stuff alley.
So I got into it. This is Mahesh. I got into it because of my kids. They wanted to do some design work, and overall, I think they're 4 and 8, so we're not expecting magic. But we'll show you some of the stuff that they've done. And I just like playing with technology, so this was another area that was just of interest. Lastly, our colleague Yom couldn't make it to this presentation, but he comes from from a programming background. And so he was just interested in the technical natures of how this stuff works. And he actually set up something called Octoprint. We won't be showing that today. We'll do it on a different webinar, but it is a cool technology for print management and 3D printers. Back to you, Hansi.
All right, thank you, Mahesh. First thing first, before we get into all the processes that involve with 3D printing, let's go over a little bit what we'll be talking about and what we hope you learn from our presentation today. We'll basically kind of say, okay, what 3D printing is all about. We'll talk about the process of 3D printing, what kind of material that you use, and what kind of software that you need to start with 3D printing, and some of the costs associated with that. And we also, as with technology, we have some limitation. Also look at some of the safety aspect of 3D printing as well. And then we hope to share some resources with you that you may find useful if you are like a beginner. So we'll share some of those resources with you. And then at the end, we'll kind of show you what we've been printing for the past couple of months. And then we'll try to take some questions for you at the end. And keeping in mind that we're also beginners, so we'll try to answer those questions to the best of our abilities. All right, let's get started. So basically, what is 3D printing, you may ask? It's basically taking a 3D model and you're creating a physical object from that. So that's just a basic definition that you will find on the internet or anywhere about 3D printing. As a beginner, that's pretty much, that's just the basic of it. And then others may ask, okay, what if I get into 3D printing, what can I print? There's a variety of applications for 3D printing. As you can see, recently for COVID-19, we had face shields that were being printed for medical workers by a lot of makers. So that was a really good thing that happened. You can also use 3D printing to print stuff to use around the house. As you can see, one of the pictures we have on the screen, like a USB stick holder. So different applications. You can also use it for prototyping. As you can see on one of the images on the screen, a prototype of a small engine. So you can actually see exactly how the engine works. It's not just in the software, you can actually print it and actually see how all the mechanism works. And also there are other applications where, let's say if you're an architect, you can actually print a small model of your design so you can actually see the different parts of your design and be able to touch it. And of course, if you're like me, we're just into 3D printing just to have fun. There's a ton of fun stuff that you can print, even if it's stuff you don't design on your own, but a ton of stuff that you can actually download off of the internet and print and display around your house and share with friends and stuff like that. And what do you need for 3D printing? So this is what we'll talk about, some of the logistics. Of course, you need software, some kind of 3D design software. And again, as I mentioned earlier, as a beginner, that's not something, if that's something that freaks you out, you can There's a ton of free models you can download online on a website like Thingiverse or My Mini Factory. A ton of really good design people already have online. You can download them and just print them on your own. So we'll talk about the slicer. So what is a slicer? Slicer is pretty much a software that takes your 3D model and convert it into something that your 3D printer can understand. So that's pretty much what this software, the slicer is. And Mahesh already mentioned about print management. Printing is straightforward, but there's other also really good option in terms of print management out there that you can use. And of course, we talk about the hardware. To 3D print, you need a 3D printer, of course. and we'll talk a little bit about the material that you use, the kind of material that you will need to be able to 3D print your models. And of course, there's a variety of tools that you will need as you 3D print. And of course, we have tweezers, pliers, and calipers that you can use for more precision printing, and also different materials like glue sticks and stuff like that. Okay, 3D printing follows a basic process, right? First, you start with a 3D model. Again, whether it's something you design in your own or something you download off of the internet. And from that 3D model, you export that model into what they call an .stl file. So this is a file that you can import into your slicing software. And what the slicing software does with that file, it kind of breaks it down into layers. And then also there's a lot of other additional information that you add within your slicing software, as far as temperature, the printer profile, what kind of printer, what kind of material that you will be using for that particular printer. All that information is assembled within your slicing software. And then from there, you export, you create a file, what they call a .g code file, that you're ready to send to your printer. Once you send that file to your printer, you're pretty much ready to press print. And once you press print, and the final result is you come from your 3D model and you get a physical object that you can actually hold in your hand or share with your friends and kind of brag a little bit. And we'll talk a little bit about the type of 3D printers. 3D printers use different type of technologies. As you can see on the screen, there's many type of technologies, but the two most common one we'll focus on is what they call fused deposition modeling, or FDM. And we also talk about stereolithography, or SLA. What is that technology all about? So it's very simple. As a beginner, that's pretty much all you will need to know. It's a technology that takes plastic. The plastic is then melted, and then as the plastic is melted, your object is then laid out on a platform, layer by layer, to create your object. On the screen, you see an example of a FDM printer, where you have a spool of plastic, and the plastic is fed to the printer. And you can see here where there's a print head, just like a regular printer, there's a print head where the material comes out and then form the object. And of course, I mentioned stereolithography technology. It's pretty much the opposite of FDM. It doesn't use plastic, but it uses something, a material called resin, and we'll talk a little bit more about that later on. And a lot of you who were thinking about 3D printing might start asking the question, okay, what printer should I buy? Well, there's a ton of options out there in terms of what's in the market. But a couple of things you might want to consider as a beginner, right? We have printers that come pre-assembled, and you have printer that comes in kits. So as a beginner, this is something you may have to start thinking about. So for example, pre-assembled printers, they come ready to run. They're tested, they're calibrated by the manufacturer, so you don't have to worry about anything. And of course, you have more options in terms of customer support. If something breaks down, you have somebody you can call, you get part replaced. The downside is it's a little bit more expensive, so that's something you may want to consider. Or if you buy a kit printer, the cost tends to be lower, but the downside is you have to put it together by yourself. As you can see behind me here, mine is a kit printer. There is a different level of difficulties in terms of kit printers. There are ones where you have to put all the electronics together on your own. Macro printer, all the electronic already come pre-assembled. Most of the assembly you have to do is putting the frame together and some of the other components. It's very easy to do. Again, it takes a little bit of time to put it together, but if you mechanically inclined, that's something that shouldn't scare you. But of course, if you feel like I don't want to put a printer together, your option may be, okay, I want to look at a pre-assembled printer. That way you kind of limit that scare from the beginning and just get right into enjoying 3D printing. And of course, there are different style of 3D printers out there. You have what they call flatbed 3D printers. And one thing you might want to consider as a beginners are, for example, the different bed types, right? You will have heated bed type and you have non-heated bed type. And this is one of the reasons why you might want to consider a heated bed type is because, for example, when you're printing, your first layer is actually the most important layer of your print. You don't want that layer to move once it's done, once it's laid out. Because if it moves while you're printing, you could be 2 hours into your print and your model moves, and then of course you have to start over. Your print job will fail. And as you can see here for this technology, you have a plate, you have a platform that moves back and forth on the X and Y axis, and then you have a print head that also move on the X axis and also move on the Y axis as well, up and down. And of course, the other thing you can consider as you're looking at the flatbed printer is what they call a flexible plate. A flexible plate is something that's on top of the platform. It makes it easier to remove the model off the printer once the job is done. And also, you may want to look into what they call a magnetic plate. Some plates are not magnetic. They get held together with some kind of plastic. So you might want to get a plate that's magnetic. Of course, that's a really thing I want to emphasize a lot. You do not want your platform or your plate to move. You don't want the model to move while it's printing. Otherwise, your print job will fail 2 or 3 hours into it. Another thing you can consider is whether you get a glass plate. A glass plate is something that you will probably learn if you get into 3D printing. That's something you learn about as you get more experience. With a glass plate, you get your first layer. You get a really smooth surface on your first layer. Most of the plates usually they have a small texture to it. So your first layer, once you peel it off, the plate will have a little bit of texture to it. But if you want to print an object where you want your first layer to be your bottom layer to be smooth, you might want to consider getting a glass plate for printing, of course. And another thing you might want to consider is what they call the bed size. The bed size kind of determines how big of an object that you can print, pretty much. And also they have what they call the extruder type, right? Extruder is pretty much the print head. And of course, there are printers that come with single extruder. Most entry-level printers come with a single extruders, but there are printers out there with the dual extruders. The dual extruder allows you to print with multiple colors at the same time. But again, if you buy a printer with dual extruder, they tend to be a little bit more expensive. The Ender Pro that you see on the screen here, this is an example of a flatbed printer. It is also a printer that uses FDM technology. This is the exact printer I have behind me here. The print size is you can print really decent sized object with it, 8 by 8 by 9 approximately, and the resolution is pretty good, about 0.1 and 2.4 millimeters in terms of resolution. You can really get high detailed print with that printer as well. And it uses different type of material, plastics, and we'll talk a little bit about that. And of course, as you can see, the price range, it's really affordable. If you're a beginner, the price is really not a barrier for this type of printer. And of course, the other style of printer that you will find out there in the market is what they call a delta printer. It is the exact opposite of the flatbed printer, with the idea that the print head moves a little bit differently in many directions. And we'll talk a little bit more about delta printer as well later on. And now I will pass it on to my colleague Mahesh, and we'll talk a little bit more about SLA printers. Mahesh, take it away.
Okay, thanks. There was a question in there about the cost of that printer. Yeah, it's $200. It's one of the reasons we got these things. You can actually get them sometimes on for even under $200. The Creality that he just mentioned, there's different levels. The Ender Pro 3 is the one that we show that he has him as well, and that goes anywhere from 180 up to 250 depending on the accessories you buy. What you see on screen now is called the Monoprice. Monoprice sells just a variety of stuff on the internet, and they happen to also resell printers. The MP Delta the MP SLA that you see on the screen is actually under $200, and it uses liquid resin. So the liquid resin printers, basically what they do is, it's very similar to what happens when you go to the dentist. The dentist uses a UV laser to harden the filling, and this works the very same way. It has a laser that hardens the liquid resin that's in a reservoir, and it basically starts building the object by hardening different parts of it, and slowly the object itself starts coming out of the printer. Next slide, please. The other one is, and this is what I have personally, is a Delta printer. A Delta printer is prints slightly differently. It actually has a range of motion, kind of like an articulating arm, rather than a XY printer. And what it does really well is it takes a lot less space, and that's one of the reasons I bought it. The space that it prints is actually a circular dimension on the XY axis, and the same height on the Z axis. One of the benefits of that, like I said, was that it's a much smaller form factor. It's got a little handle in the top so I can carry it around. And it has a heated bed. And it goes anywhere from 150 to 200. I bought mine during Thanksgiving, Black Friday for, I think, $149. And so you can go to Monoprice and keep an eye on the prices, and it's a good option. And it also has something called an auto leveling bed. That really helps when you're trying to initially configure your printer to make sure that it prints correctly, especially that first layer that Ansi was talking about. And then the last thing is, this is actually for my kids. I actually have one of these things over here. It's actually a 3D pen. It uses the same technology. What it does is you actually take a filament and you put it in the back, and it works very much like a hot glue gun, and it actually heats up the print head, and you can actually start printing by writing. The benefit of this specific one is its temperature is low enough that it can melt the plastic filament, but it's safe to touch. And we've actually done things that we've printed that we'll do during our show and tell later. I think back to you.
Mahesh, we had a quick question online asking which is more expensive on average, filament or resin?
That's a great question. Depends on what you're printing. Filament is usually cheaper because you can get it on Amazon, usually during sales. Resin has a much, because it's a liquid that you have to take care of, maintain, and it actually degrades over time, it's probably more expensive to maintain resin for long term. We'll be talking about pricing shortly as well. I think standard resin, $25 or so. Is that right, Hansi? I think you're muted.
Yeah, somewhere around that price range. Can you hear me?
Yeah.
All right. Thank you, Mahesh. Again, one of the things that you mentioned earlier is about the type of material that you will need to print your 3D print. Again, there is a variety of materials out there. One of the most common that's used by entry-level makers is what they call a PLA. It's a type of plastic, and it's less toxic. And also what you will find out that you have more color options in terms of if you want to really print some really cool stuff, you can actually find a lot of really exotic colors in PLA. Other type of plastic out there that you can use are ABS. ABS is a little bit harder to print with because you need more of a controlled temperature environment. And if you think you might be, this is the type of plastic also they use for Legos, to print Legos. So if you thinking about getting an ABS printer, you might want to get a printer that has an enclosure. That way you can control the temperature at the overall environment, have more control over the environment. And of course, you can print with nylon, carbon fiber, TPU. TPU is more like a flexible plastic. This is the kind of plastic they use to print toys, or if you want to print a phone case, you can actually use TPU for that as well. I mean, keeping in mind that TPU, you might want a more controlled environment as well because temperature. And of course, they have PLA infused with wood. You can actually have your print have like a wood texture. And also they have glow in the dark, etc. Again, there's a ton of options out there in terms of PLA. Again, the one I have on the screen here is the one that the one on the screen. This is the one I'm using at home for my prints. Again, it's typically used is sold in a spool, as you can see here on my screen. You buy a spool, and it also measured in weight, so either in kilogram or grams. And one of the reasons why they measured it in weight, as you will see a little bit later on, when you slicing the model, it actually gives you an estimate as to how much plastic it'll take to print that model. So having the spool in that kind of measurement will tell you, okay, oh, do I have enough plastic to print that particular model? And as you can see here on the screen, they have those little markers that tells you how much plastic you have left on the PLA. I mean, on your spool. That way, if I'm printing a model that's gonna take about 200 grams of plastic, and I have about 100 grams of PLA, I definitely don't want to use that spool because I will only be able to print half the model. So this is something that, again, like I said, there's a ton of options out there. You just gotta do a little bit of research, making sure that you get something that really good reviews and you get some really good print. The only thing I would mention is maybe avoid trying to get the really cheap one, because then as a beginner, you really don't want to get frustrated about print that fails. Also, it could be a really good way to learn, but some PLAs, because by the nature, if it's too cheap, sometimes those prints tend to fail a little bit more often. And now I'm going to pass it on to my colleague Crystal to talk a little bit more about the type of software that you will need to create your 3D prints.
Hansi,
Crystal?
before we get into the software, we have a couple questions regarding the filament and resin. If we could touch base on those real quick. There's a question. Can you use various filament types in one printer, for example, wood and plastic, or is it just only one?
Yeah, most printers will actually support multiple type of filaments. As you can see, the one I had earlier, the EnderPro, supports PLA, TPU, a variety. So when you look at the specs for a printer, it'll tell you exactly what type of material it's able to print. So that's one of the things you can look at. And of course, resin, the exact same thing as well. They will give you, based on the specs, exactly what type of material that you can use for that particular printer.
Perfect. That answered one of our other questions we had. And then finally, you kind of alluded to this. If you're working on a project and you run out of resin in the middle, are you able to just stop and refill it, or do you have to start over?
I'll let my answer answer that question. I'm not too familiar with the resin printer, but I'm more familiar with the FDM printers. FDM printer, you do have the ability to actually pause your print. So you can pause the print, refill, replace the spool, and then continue the print. So that's, yes, it's possible.
Yeah, and same on the resin, you can fill it in as well. It does use ultraviolet, so if you notice that the screen, the covering was actually a type of glass that filters ultraviolet, so you just have to be a little bit careful on refilling.
All right, perfect. Those are the questions for right now, so we're good to move on.
All right, take it away, Crystal.
Can we presenter?
Stop sharing and make Crystal the presenter.
All right. Just gonna give everybody a warning. It is pouring right out here. Hopefully my internet stays good. All right.
All right, Crystal.
Got it. Okay. So. Okay. Hold on, sharing's being a little weird. Do you guys see the presentation?
We see, yeah, we see a
Yes.
presentation
Okay.
in Firefox in the background, but nothing else.
Nothing else? Okay, let me get the other one up. There we go. Okay. So you should see both now, correct?
We see
Okay.
Tinkercad now.
Perfect. Okay. Okay, so I'm going to quickly go over a very loose demo on how to use 3D modeling apps to make 3D designs for yourself. You can find a lot of really cool stuff on the web already, STL models that are already done. But if you want to make your own things, I mean, Tinkercad is free. It's an online app provided through Autodesk, and it is super simple to use. I'm actually going to show you guys how to make a 3D wrench. And my internet's going very slow. There we go. So, but we're going to go through, I mean, there's a lot of software out there. Tinkercad's a great free one. Fusion 360 is another one that is partially free to a point. I believe students have a free version, and I want to say they even have like a free non-commercial version now. And then there's slicing software, and the slicing software that Hansi mentioned earlier is what converts this three-dimensional wrench into code that the printer understands to print. And also you can change the mesh and stuff, but I'll show some of that a little bit later. I would say the biggest hurdle most people get into when they first jump into 3D programs like this is how to move in 3D space. People get very frustrated very quick if they've never done it before. Tinkercad's very, very straightforward. It even has this cute little tool up here that lets you quickly spin around. You can click on it. So if you're not comfortable with the mouse commands and shift and all the hotkeys that let you manipulate space, you can certainly use this little tool up here to get around pretty quick. So I'm going to go quickly over how to build something real fast in 3D. So I basically grabbed a block out of their predefined shapes and I've squashed it, and you can stretch them. You can change their shape however you want. And I'm going to replicate this wrench that I have here. So quick shape, drop a cylinder, squish it. And you can do, you know, Control C, Control V, let you duplicate shapes. So they can be the exact same size, the exact same length, the exact same height. Now to cut holes in things, I'm gonna go down a little bit and find the polygon. And just from playing around in the app, I've learned that if I want to take this back out later, it can be a little difficult. So I'm going to smush it down a little bit to make the inside of the wrench a little too big still. There we go. I like leaving them a little bit taller than the object itself, because what happens is if I need to take this out later, it's really, really hard to grab if it's inside. So it's a little hard to grab that object again if it's inside the other object. So I like to have a little bit of top on it. Now, one thing is, since this needs to be pretty even, what you can do is you can select all the objects, and up here is an alignment tool. And it gives you these little dots that lets you align the objects, and it'll give you a preview. So you see how it pulls everything together for centered. It'll basically center everything in the center. But I'm mostly looking to align them down the middle. So, oh shoot, wrong one. So I'm gonna grab these two, like that, align, and I'm gonna center them both, center and center. And now that's perfectly centered. And to cut holes, you select this shape, tell it to be a hole. And then you just go up here and make it a solid object. But you see how the bottom's there? That's because my inside object wasn't all the way to the floor. So I'm going to actually scale it a little bit. Second. So now if I do it, it should be, there you go, now it's a full hole. So for this side, pretty much the same concept. Grab a polygon, squish and, squash and stretch, and I give it a little bit of a curve. You can use these little tools on the side to turn your objects. You can also set your degrees manually if you know what you want. Obviously that's too far, but so you basically just kind of do this, slide it in, and then do the same thing. Shape, not shape, sorry. Make a hole first. Hole, and then grab it and make it a shape. And I mean, that's pretty much the wrench. You make it a solid object. And now I can take this and I can go up into export, and I can export it as a object or an STL file. Either is fine, honestly, for your slicing software. It'll take either file type. So I'm going to go ahead and export just this one because it's already built. So we're going to export it as an object file. So I'm going to open it up in Cura. Second, I got to share Cura.
Hey, Crystal, while you're doing that, I don't know if you can take questions too, but we had a couple questions about some other software.
Yeah, of course.
Exporting directly out of AutoCAD.
Mm-hmm.
Asking if that can be used. Let me see, there's a couple others, Cinema 4D
Yeah.
and SolidWorks. All those are acceptable programs to use also?
Yeah, as long as you can get them out as an object or an STL file, you can pretty much dump it into your slicing program, and the slicer is what basically re-encodes the file to be, I don't know, I guess, readable by your 3D printer. That's what helps you build your walls and all that sort of stuff. Sometimes, I mean, sometimes when you have planes, it does depend. It's some of it's trial and error, to be totally honest with you. Like when I'm making stuff in like Tinkercad here, these are all solid objects, but some things build stuff with planes, and I think that can get a little bit clunky. But I mean, we can go over stuff like that like on another one later, is how to like make planed builds that are like done with dots and points into solid objects. But I'm going to quickly open up this object in Cura. Let me get Cura shared. Share. Can you guys see Cura? Should have came up.
Yep.
Okay, perfect. So I guess I completely forgot I had this up. Okay, so this is Cura. Let me make it a little bit bigger for me. I don't know if it scales for you guys, but okay. So I've imported the wrench into Cura 3D, and I have preset the printer to be the Ender 3, which we have at the office, and Hansi has at his house. And so my wrench is in here, and there's a couple settings you can go through. One of the biggest ones you got to worry about is density. That's how much filling is on the inside of this object. I believe you can also change some of your walls and stuff in here too. Short and the long is your infill is going to dictate how thick the object is. Is the object for form or for function? If you need it for function, like if you actually wanted to use this wrench, you would probably need a high infill. If this wrench was just going to sit on your mantle, you would want a lower one because it can be thinner. You don't need to waste material. So I'm going to quickly close this, and let me make sure there's a couple things off here. Let's see. I think I might have tree support on, but we'll see. So if I do preview, you can see that it basically lets you look at it line by line, exactly how the printer is going to print it. Even will show you a mock-up of the print head running layer by layer. And as you can see, it has a very thick infill because I set it at 70%. Now, there's other things that you can do. Let's say you're printing something that has a weird shape or is really vertical. You can run the risk of things collapsing then. So what you would want to do is build something with tree or supports. So here, let me see if I can let me spin this. Oop, let me out. Ooh, okay, it's not letting me grab it again. Hold on.
Crystal, is there a reason why it only skirted part of the wrench?
What do you mean?
I don't know. That was a question from Charles.
Probably because it's
skirted.
it's not completely aligned. I'm trying to look underneath of it here and see what's up.
The skirt that you see around the printer is actually to just feed out a little bit of the toner of the PLA so that it kind of clears the print head. It's sometimes also used to create a way to easily pick up the object from the base.
Let's see what it looks like with the raft here. I mean, you can do adhesion plates with the raft. Hold on, let me see if I get in there. I don't know why it's not giving me these options. Ooh, that's kind of weird. Okay. Huh. Yeah, I don't know. Cura's being a little bit funny. Let me see if it'll let me in. Yeah, it's not letting me grab.
You have to get out of the preview mode.
Yeah, it's not letting me. Oh yeah, let me see. Okay. Yeah, there we go. Yeah, but now it's. Yeah, it's being a little weird. Like it's not letting me grab it again. I don't know. This is their new version, so. Yeah, it's only letting me go into preview. It's not letting me come back out for some reason. It's really strange. I'll just re-import it.
Crystal, can you explain a little bit more also about infill? What exactly that means for some of the beginners?
Yeah, sure. Yeah, hold on. Let me reopen this file so I can actually go. Yeah, it's not letting me grab it again. It's being a little bit crazy. I don't know what this deal is. There we go. Yeah, so here, let me go ahead and flip it, and I'll show you what it looks like when it builds a support structure. But I'll go ahead and slice it again too, and I'll show you the infill. So here, my infill was 70. So I'm gonna go ahead and slice it real fast. It should build me a tree. Yeah, see, you see all that stuff it built up here? This is called a support structure. I personally like using the tree support. I find that it's a little bit lighter. I don't use as much material, and it's like organic. See, so I don't know. I'm a fan of tree support. Okay, so infill. So I'm going to zoom in real close. You can see the infill. So infill is basically what it puts in the center of the object, how thick or how thin that is. So here we go. It's a good spot to look at right here. Okay, so I'm going to drop this down to, let's do like 30 so we can see it. I'm going to slice it again. And then I'm going to bring up the, okay. See, you see, if you can look at the infill, you see how it's not super like dense now. If I bring this back up to 70 and reslice it, it's going to be a little bit thicker. It puts a little bit more in there, and you can also change the pattern. Like where are we? I believe concentric is actually one of the better ones for real sturdy structure. It will fill it. It's because it's pinned kind of crooked, so you're probably not really getting a good look at it, honestly. But
Here we're coming up to our time marker.
Yeah, I'm gonna clip off.
Keep us moving.
Yep. Let me stop sharing. Okay. Let me give it back to Hansi. Okay. Obviously, questions, just ping us.
All right. Again, thank you, Crystal, for your demo. Again, as we'll talk a little bit more about some of the limitations of 3D printing. Of course, with any piece of technology, you have limitations. Like I said, if you're a beginner, if you're looking into doing prototyping, like I said, there's not a single solution out there for what you're trying to do, for the type of applications you're trying to do, or the type of material you're trying to do. So you just have to do a little bit of research and find the solution that fits your application much better. And of course, in terms of processes, we covered that a little bit in terms of all the different process designing and slicing. There's not a one plug and play system as of today. So you still have to go and do some of the other steps that before you can start printing, for example, designing, or whether you download the object, you still have to do some of the prep work in terms of slicing and stuff like that. And as Crystal just mentioned, sometimes you may have to do some post-processing. For example, if you print a design that requires a support, some of that support you have to remove it after the print job is done. and it depends on the complexity of the object or of the model. It might take you a little bit of time to remove the support. This is some of the post-processing. Some people actually go even further than that. They will print the model that in a more like neutral color, and then they would paint the model or sand it to make it look more realistic, or just, you can do some really cool stuff post-processing. And of course, we have to talk a little bit about safety, right? You're dealing with electronics and power, so you have to, and heat, you have to talk about safety as well. So as a beginner, if you look into purchasing a 2D printer, the first thing I would say, once you get your 3D printer, take some time to read the safety instructions that's provided by the manufacturer. And also, if you're printing in your home, make sure the area is large enough and well ventilated. That way, you're dealing with plastic, so you don't want to, inhale any toxic fume and stuff like that. And of course, you definitely want to use the materials that are recommended by the manufacturer. Of course, they will tell you what kind of in the spec, they'll tell you what kind of material that your printer supports. And of course, as a beginner, I would definitely recommend using PLA because it's not a toxic material. And also, if you go into the resin-based printer, they also have plant-based resin that's a little bit much better for your health. And of course, as you print, you will accumulate print dust and scraps. So you definitely want to keep your printer area clean because you don't want anything to catch fire. And of course, electronics, you want to turn it off when you're not using it, just in case you have some kind of spike of electricity. And of course, keep flammable items away from your printer because, for example, for the FDM printer, the print head can get heated up to 200 degrees. So you definitely do not want any flammable material near your printer as well. And if it's something that, and also in terms of hot surfaces, if it's something you want to start doing with your kids, you want to get them involved with 3D printing, you just got to be aware that there are areas of the printer when it's printing that gets really hot. You definitely you do not want a toddler to touch it, or even as an adult, you do not want to touch it because you will get burnt. 200 degrees, that's hot. And of course, one thing you did not want to do is do not leave your printer unattended. For example, one other thing I like to do when I'm printing a job, I want to make sure I sit there and look at the first couple of layers, making sure they're sticking to the plate, because I do not want to go 8 hours into a print job and then it fails at 8 hours. It could be devastating. So you definitely want to take a look at the print job, kind of go back and forth, kind of keep an eye on your print job. And of course, we mentioned earlier, there are other technologies out there that allows you to monitor your print job remotely and be able to stop your printer if the print job fails. You don't want to end up with a big mess, if your print job fails. So that's a little bit about safety. And of course, we'll talk about resources, this type of software you can use. We have Tinkercad, Simplify 3D. Simplify 3D is more like a paid software, but it has a lot of really good features. If you're, something you might want to invest in, it might be worth the investment. We also have a couple of resources in terms of where you can actually purchase some printers, and a couple of websites where you can actually download free model to get you started. As a beginner, you might not want to get into like designing. You might want to download some models and then start playing with them so you can get familiar with the technology. Once you get more comfortable, and then you can actually start learning about to create your own design and print it and have fun. And for me, just having fun, just doing different design and downloading this different design and see what they look like. And of course, this is pretty much all for our presentation. And what we're going to do now, we kind of show you over the past few months, this couple of things that we've been printing. So let me go ahead and stop sharing my screen. And then I switch to my camera.
Hey, there was a quick question, Hansi, about what do you do when it doesn't stick to the plate? And I think we actually use a glue stick. You know those things you use for kids? That's what we use.
Yeah, definitely.
Some people use hairspray and they hairspray the bed, but glue stick works the best.
Yeah, definitely. So that I can't find my glue stick now, but you can use a glue stick, painter's tape. That's what I was talking about, the type of bed. So some printers use painter's tape, they're not heated bed. So yeah, so you can glue stick is definitely. Lately, I've been finding out that I have to use glue sticks to get my model to stick. No matter how much I level the bed, sometimes I have to use the glue stick. So yeah, so let me show you guys a little bit of what I've been printing for the past couple of months. But again, it wouldn't be funny. I think it's very fitting that the first model I want to show you on the screen is the actual SpaceX logo that I downloaded off of the internet, and then I printed that last night. It took about 25 minutes to print that particular model. It's pretty cool. In fact, I didn't remove it off the bed yet. So this is one thing I wanted to demonstrate as far as how easy it is to remove the printer from the plate. So as you can see here, I have the job. I can flex my plate. This is where the flexible plate comes really handy. I flex the plate and already the model is already coming off the plate. And I can just peel it off and I have my logo. And it's really fun. And as you can see here, this is the plate. It's flexible and it's magnetic. So when I put it on my printer, it's not going to move. So my print job, I know for sure my model is not going to move and my print job is not going to fail. Other things I want to show you is the actual bridge that Crystal designed earlier. She sent me the file and I downloaded it, processes it in Cura, and I was able to print it. It took maybe 13 minutes to print that. It's a really small print. As you can see, I'm bending it. It's really tough. I mean, you can actually use that to remove an actual screw. Other things that I've printed, let me put that on my bed. I printed small parts like that for my boat. I had a boat and a part kind of broke off of it. So I took some measurement using my caliper. This is where your caliper comes in really handy when you really want to have really precise measurement. So I took some measurement and I was able to replace the part that's broken off my boat. I didn't have to buy a whole new boat. That's the fun part of 3D printing. And of course, a ton of other stuff you can print, but the most special to me is this one. And if you can see, I had to get really creative, guys, during COVID. It's like, okay, what am I gonna do for Mother's Day? So I went online and downloaded the model, and this one kind of say mom number one. And I did all my photoshopping, printed that model. It took a couple, because that particular model come in 2 separate pieces. It took a little bit of time to print it, about 12 hours per piece. So I printed that and did a little Photoshop, put my boys' pictures in there, and mom was really happy about that. So you can get really creative with 3D printing and while you're having fun. And of course, if you're more serious about it in terms of prototyping, it's a really, really good tool to use for your design. And I'll kick it off to Mahesh to kind of show you some of the stuff that he's been printing. Mahesh?
Much simpler stuff than his. His is more complicated. This is, by the way, a glass plate. It's actually got a little piece to grip onto the system, to the base. But this glass plate actually allows me to put a glue stick. You run the glue stick on it, and then I print on the glass plate. The heat actually goes through the glass so that I can print on top of it. Most of my stuff is actually kid stuff. These are things that my kids designed. This, for example, is a hovercraft. It was actually printed on an FDM printer, a flatbed printer, and it was printed as one piece. Perry, actually, in engineering, helped me design that and get it going. This one's actually a bracelet that's printed out of multiple pieces that we then super glued together. It's supposed to be a watch from a kid's TV show. And this one is actually using Tinkercad. My 4-year-old actually did this for Mother's Day. He printed this. He just joined all these different objects together and just together, and it's a ring. So guess what? You can wear it as a ring. So that's what that is. Here's something actually useful. This is a hinge that you can print. Let me get it in there. and you just join the hinge together. And then the 3D pen that I showed earlier, this was actually something that my older son did. He actually just used a 3D pen to just kind of layer it using your hand and came out with a fish. And that's pretty much all I have to show on my end. It's mostly kid stuff. Crystal has much more fancy stuff. Go ahead, Crystal.
Hansi, can you switch presenter mode to Crystal while she shows off, please?
Oh yeah, you don't need to switch presenter. I'm just going to show him on the camera. So I don't know if you can see him too good. It's a little dark in here, but you know, I play D&D because I'm a giant nerd. So of course, the first thing I went and tried to do was to print up some figurines, and these I printed off of the Ender 3. I pushed our nozzle as low as it could go, and they came out okay given their size. But you know, then I have the Mandalorian. And as you can see, I don't know if you can see or not, but his arm fell off because, I just couldn't get the model down small enough to functionally print it. So this is where a resin printer would come in far more handy for doing this sort of stuff. I think we're going to have Melanie come show some stuff because she does like the large cosplay pieces, and she has some pretty cool stuff. That'll be like a later one, I think. But all right, going to hand it back. Hansi, I know you wanted to show something on your deck, so.
Like I mentioned earlier, let me switch screen. Like small parts, and one of the things Crystal mentioned earlier is the part with support. Oh, mine fell off. Okay, as you can see here with the particular design, so I needed a support for the part that was kind of like an overhang. So your printer cannot print into space. So for that particular area here, I didn't want it to fall off. So this is where you actually, one design where you actually need a support material to be printed so that your design doesn't fail, your print doesn't fail. All right, let me go ahead and switch my screen here. All right, so we've already took quite a few questions. So we'll take a few more questions if you have questions. And also at the end.
Come into the question, the Q&A.
Before we get to the questions, we have a couple minutes. I would just like to put out a reminder. This is the first in a series of webinars we'll be hosting in regards to 3D printing. Based on the feedback we received from the surveys, we will be determining future topics, and these sessions will be for all different levels in 3D printing. So whether you're a beginner, a novice, or an expert, throughout the coming months, we will have different webinars available for you. There will also be a recording of this video on our YouTube channel within the next 24 hours. You can find our YouTube channel at FAU Libraries. That's the same handle for all of our social media also. So that's the best way to stay in touch with us for the upcoming webinars. So at FAU Libraries on social media and YouTube to see a copy of this presentation. Those slides will be included in the email with the survey that you'll receive shortly after the conclusion of this event. We can jump into some of the questions. We have a couple minutes here, and let's look at see what some of the ones we might have missed.
There was a question on bed leveling and the size gap. You want to keep that as small as possible, under 1 millimeter, if at all possible, and that's where auto bed levelers, the systems are more expensive, but can auto would help. A lot of it is experimenting. Some people actually use just a paper to slide between the two, and that might actually be a good demonstration of a future session that we might do.
Someone had a question, is there an advantage to using the monitor feature in Kira, or will the 3D be best? I think it's probably for Crystal.
Monitor feature in Kira, hold on. Oh, when you get to watch the job? It depends. I mean, if your printer's connected directly to Kira, I mean, absolutely. But, if you don't have the printer directly connected, then obviously Kira can't monitor the, line by line print. But I mean, yeah, it's really great to be able to watch it. I know we wanted to do a little demo on what's called Octoprint, and we'll do that later. And Octoprint is basically a web app. You can build it on an Arduino, and you can monitor your print remotely. You can shut it down remotely. And that's something that for sure, you know, when I get my 3D printer, I will be doing that because I know me.
All right. Someone asked about rafts and brims, which
I think that was during mine. Let me see. Yeah, rafts and brims. I don't know. I guess it's preference. Some people like to do rafts. Some people like to do brims. I've done both. It just depends. I find that rafts can sometimes be easier to pop models off plates. But if you have a flex plate like Hansi does, and you don't necessarily need a raft because you can just flex it right off. Sometimes if you're using the glue sticks, the tape, then you can kind of just peel it off. So honestly, it's trial by fire sometimes with these prints. And, you know, I wish I could show the picture of my first print. It's literally just strings exploding all over the place. So.
All right, we have a question about if there are 3D printers available for public use in the library in the future.
So right now we don't public use, but we hope that we get enough interest because we know there's people far more experienced than even us at the university, but within individual colleges. And we hope to kind of bring those people together in a central place that's multidisciplinary, sort of a neutral ground at the library, at the hub, kind of like a hub, and share our learning and teach each other from that, both for students, staff, and faculty, of course. And we will be hosting more workshops. Fill out the survey.
Yes, nice little plug there, Mahesh. Absolutely. That's what's going to give us our feedback to do more of these webinars in the future and also to better serve the FAU community. So if you are interested in learning more about 3D printing, if you're interested in getting more hands-on, we look forward to reopening the library at some point in the near future, hopefully. And from that, and based on the feedback we get, we always listen to what the community wants and do our best to provide that. So filling out that survey is the best way to make sure we hear what you're interested in. That's going to take us right up to an hour. So we're going to go ahead and wrap up this presentation right now. I want to thank Hansi, Crystal, and Mahesh for their time this afternoon for putting together this presentation. I want to thank you all for your patience. There were a couple technical hiccups that we encountered, but hopefully it didn't affect the viewing experience that much. So thank you all very much. Make sure to be on the lookout for that survey and the recording of this presentation. And we hope you all stay safe, and we can't wait to see you in the library sometime soon, hopefully. All right, everybody, have a great rest of your week.
Thanks, everyone. Bye.